Okay, so as you guys know, Doug Ford made an announcement yesterday that you guys will be online and learning from home up until February 10th. So that means I basically don't get to see you guys for the rest of the semester. But you know what? It is what it is. We had our fun together when we were in person, the few days a week we were in class. It was great having you guys. You guys were pretty funny and just overall a very smart class. So yeah, so sucks that we couldn't spend more time in person in class, but that is the nature of things. And honestly, just prepare to be online for the rest of the year. With Ontario projecting their numbers to be in the 20,000s, I think it's safe to say that you guys are going to be relaxing at home, learning, and getting your high 90 average and getting into your dream university. So yeah, and then we'll all be stuck at learning from home. Oh, and also if you're wondering, I have to teach 2 sections of locally developed grade 9 math next semester and a grade 11 philosophy, which I didn't know there was such thing as grade 11 philosophy, but apparently it's a social science course. So those are the 3 courses I am teaching next quad. Well, locally developed math and philosophy, the first quad, and then locally developed math, the second quad. Okay. So yeah. So like I said, if you guys ever have questions or some of you have reached out to me in terms of me being a reference for you guys on your university applications, just ask me and I will gladly do so. If you need a letter to be written, I can write it for you, or you can write yourself a letter, or you can write the letter yourself and hype yourself up, and then I'll just sign off on it. Okay? So if you ever need those types of favors, I will gladly do so. I remember my fiance's brother needed a reference letter, and the professor that he asked for a reference letter told him to write the reference letter himself, and he just signed off on it, and that was basically it. Remember, guys, sometimes it's harder to talk about yourself positively because you don't want to seem arrogant, which is why writing these letters yourself may be hard. But just let me know what you need, and I'll be glad, more than happy to help. So yeah, and also for my stock portfolio, I added, for those of you interested, I added more Apple shares, more Cloudflare, and the Neo stock. Again, I'm holding these for like 5 to 10 years from now. So I should expect to see some type of exponential growth, because for the long term, stocks tend to go up. But if you're short term, they tend to fluctuate a lot. So if you're in for the short term, you might lose money. But if you're in for the long term, you are more than likely to gain money. Okay. And there's a saying, time in the market is better than timing the market. Okay. So that's for all of you who are interested in investing. Remember, I'm not telling you what to do. You guys should be able to do your own research. And yeah, I watch videos, so if I listen to them and I lose money, that's my fault. Again, like I said, when it comes to investing, you do your own research. I can only say so much, but then again, I'm not a professional. So don't blame me if you guys get into investing and then you happen to lose money off the bat. Remember, like I said, you only lose money once you press sell. So with that said, we're going to do one lesson today, because this one's going to be a decently long lesson. We're going to be solving exponential equations. So today we're doing 7.5, tomorrow 7.6, and Friday 7.7. And that should end off Unit 7. And then you will have your CPT next week. And the week after that, you will be doing your Unit 7 assessments, and I will be teaching you rates of change. Okay, so we're going to get started with 7.5, which is solving exponential equations. So when we're solving exponential equations, we need to create powers with the same base. So an exponential equation is one in which the variable appears in the exponent, two exponential equations or two exponential expressions with the same base are equal when their exponents are equal. You won't have lessons next week for the CPT. I'll just be online if you guys want to ask me questions. So that will be like your own working time next week. And if you want to join the Google Meet, I will be available at the times we have class next week. So on Monday, I'll be on the call at 12:30, so you can join if you have any questions. On Tuesday at 8:20, Wednesday at 12:30, Thursday at 12:30, and Friday at 8:20. No, I'll just post the attendance question for next week as your attendance, and you guys are expected to answer that by 9:30 when we have our morning sessions, and by 1 o'clock when we have our afternoon sessions. Okay, so for example, we have b to the m is equal to b to the n, then m is equal to n, where b is greater than 0, and b cannot equal 1. So m and n are an element of a real number. In this case, we want to rewrite each side of the equation with the same base, and then equate the exponents to solve for the unknown. You may first have to factor out a common power. So for example 1, we want to solve for x. So we have 4 to the x is equal to the quintic root of 64. So we can simplify the right side in the way we write it. So we have 4 to the x is equal to 64 to the power of 1 over 5. So now our left side, we have a base of 4. So we need to write 64 in terms of a base of 4. So we need to find a power that has a base of 4 that gives us 64. So thank you, Jose, 4 to the 3. So our next one, we have 4 to the x is equal to 4 to the 3 to the power of 1 over 5. What would our next step be? Notice we have a power to a power. Not add the exponents, but when we have a power to a power, we're going to multiply. So we got 4 to the x is equal to 4 to the power of 3 over 5. Because the bases are the same, we can ignore them, which means x is equal to 3 over 5. And that would be the answer to 1a. So once you have everything simplified and you have the same bases, you can always cross out the bases at the end of the question and just solve for x. Okay, the next one we have is 16 to the power of 2x is equal to x plus 1. So remember, we need to write both 16 and 8 in the form of a power with the same base. So what exponent base can we use for 16 and 8? 2. So we know 16 is written as 2 to the 4 to the power of 2x, and 8 is written as 2 to the 3 to the power of x plus 1. And now what do we do with our exponents? We have a power to a power. What's our next step? We're going to multiply the exponents. So we get 2 to the power of 8x is equal to 2 to the power of 3x plus 3. Our bases cancel out, so we're left with 8x is equal to 3x plus 3. And now all we want to do next is isolate for x. So you get 8x minus 3x is equal to 3. You get 5x is equal to 3. Divide both sides by 5. And we're left with x is equal to 3 over 5. So are you guys finding the first two examples okay? Perfect. So we have example C, where we have x log of root 5, log base root 5 of 125. So using the rules of logarithms and the format is in, how can we write x log base root 5, 125? In what other way can we write this expression out? Yep, so we can write it as root 5 to the x is equal to 125, or or 5 to the 1 half x is equal to 125. So we know our left side has a base of 5, so we need to make the right side a base of 5. So how can we write 125 in terms of a base of 5 to a power of an exponent? 5 to the power of 3. So we have 5 to the 1 half to the power of x is equal to 5 to the 3. And what do we do with our exponents on the left side? So we're going to multiply. So we get 5 to the power of 1 over 2x is equal to 5 to the power of 3. The bases cancel out. We're left with 1 over 2x is equal to 3. Multiply both sides by 2. And we're left with x is equal to 6. So as you can see, these examples are not too difficult. You just want to have the same basis for the exponents. Okay, that is the goal for these questions. Get everything to the same base. So our next question we have is 2 times 3 to the power of 2x minus 5 is equal to 18 times root 3. So what would our first step be in solving this equation? I wouldn't distribute the 2. Instead of distributing the 2, what can we do with both sides? We're going to divide both sides by 2. So divide by 2, divide by 2. These cancel out, and then the 18 becomes a 9. So you get 3 to the 2x minus 5 is equal to 9 root 3. So on our left side, we have a base of 3. Can we write the right side in the form of a base of 3 for both of these numbers? Can we write 9 with a base of 3? Three to the 2 and 3 to the 1/2. Thank you, Joseph. So we have is equal to 3 to the power of 2 times 3 to the power of 1 over 2. So everything has a same base. So we need to simplify the right side though. When we're multiplying exponents with the same base, what are we doing with the exponents? We're going to add them. So we're going to add 2 plus 1 over 2. The common denominator is 2, so we get 4 over 2 plus 1 over 2, which is equal to 5 over 2. So our right side is 3 to the power of 5 over 2. Our bases cross each other out. And we are left with 2x minus 5 is equal to 5 over 2. We're going to have to bring the negative 5 over. So we get 2x is equal to 5 over 2 plus 5. 2x is equal to 15 over 2. And if we divide both sides by 2, what is our final answer? Our final answer is 15 over 4. Next ones might be a bit tricky, so just pay careful attention to these. So the next example we have is 2 to the power of x plus 5 plus 2x is equal to 1056. So how can we start this question off? Not yet. Not entirely yet. So what we can do, because we have this plus sign in the middle of x plus 5, that means we can have 2 separate exponents with a base of 2. So we can have 2 to the x times 2 to the 5 plus 2 to the x is equal to 1056. So what do you notice about the left side? Think of it in terms of algebra. Is there anything specific that we can factor out? Okay, the 2, but 2, like Jose and James, you have part of the answer, but separately. Now combine those 2 together. So we're going to factor out 2 to the x, okay? So here we are going to use common factoring. So we have 2 to the x times 2 to the 5 is left over, plus 1 is equal to 1056. So now with BEDMAS, we have to simplify the bracket. And what does our bracket simplify into? So our bracket has 2 to the 5 plus 1. 33. So you get 2 to the x times 33 is equal to 1,056. Now, what do we do next? We're going to divide both sides by 33. So you get 2 to the x is equal to 32. And now we can make the right side in terms of a base of 2. And what would that give us? Two to the 5. So we get 2 to the x is equal to 2 to the 5. The 2's cancel out. And we have x is equal to 5. So whenever you have a question that is in this form, where you have an addition, you're most likely going to have to factor out a common factor on one side. So question F is similar. So we have 6 to the x plus 1 plus 6 to the x plus 2 is equal to 7. Oh, so when we had 2 to the x times 33 is equal to 1,056, we divided both sides by 33. And we were left with 2x on the left side. So we have 2x is equal to 32 because 1,056 divided by 33 is 32. And because the left side has a base of 2, we needed to write 32 in terms of a base of 2. So if we write 32 in terms of a base of 2, we get 2 to the power of 5, which is why we wrote 2x is equal to 2 to the 5. And once you have the same bases, you can cross the 2's out, and you're just left with x is equal to 5.
Sir, can I just like ask it like this?
Sure.
No, like I meant like like the 2x and then brackets 2, 2, 5 and then plus 1.
Yep.
Yeah, like how'd you take the 2, like can you do that? Like are you allowed to just do 2x and then take that away
Yeah,
from
because think
like
of it as, so remember when we do stuff like 3x plus 9, right? When we factor out the 3, we just write down what's left over in the bracket. So we're left over with an x, and then 9 divided by 3 gives us 3. So it's the same idea as that.
so then like from the 2, 5, like 2x is basically just like 1?
Yep. Because when we factor out the 2 to the x, this part over here, we're basically dividing a term by itself. And when we divide a term by itself, we always get 1.
Okay, thank you.
Yep. So then F is a similar idea. So how would we start off question F? And Yusuf, this is going to work the same as well. So how are we going to start off question F? What is our first step? So we are going to do the same thing we did last time. We are going to split up, we're going to break up the exponents. So we have 6 to the x times 6 to the 1 plus 6 to the x times 6 to the power of 2 is equal to 7. Okay? And Jose, what is our common factor in this expression? So we're going to factor out 6 to the x. So when we factor out 6 to the x, we are left with 6 to the power of 1 in the first expression, and then we're left with 6 to the power of 2 in the second expression, and that is equal to 7. So when we simplify the inside of the bracket, what number do we get? 42. So we get 6x times 42 is equal to 7. And what would be our next step? So we're going to divide both sides by 42. So we're left with 6x is equal to 1 over 6. And now we need to write our right side in terms of a number with a base of 6. So we get 6x is equal to 6 to the power of negative 1. The base is crossed off. And we're left with 6x is equal to negative 1. Okay, so as you can see, F and G were the same type of example. So now we're going to move on to solving exponential equations. So this is the second strategy. So what if the bases are not the same? So we need to take the logs of both sides in order to solve the equation. Taking the log of both sides of an equation preserves the equality. So if we have m is equal to n, then all we can do is write a log in front of the m and the n. So we can also write it as log m is equal to log of n. So remember, when there is no real base, we always assume the base is 10. So always assume the base is 10 when nothing is written. So in this case, take the logs of both sides using the base of 10, and then use the power law of logarithms to simplify the equation and solve for the unknown. So we want to solve for x, and we want to round to 3 decimal places. So the first example we have is 2 to the x is equal to 11. So based off what I just said, what is our first step? What would we have to write? Yep, we're going to write log in front of both of these numbers. So log of 2 to the x is equal to log of 11. And the power rule we learned yesterday, what happens to the x over here? Where would it go? Look at your power rule from yesterday, and you'll know exactly where that x will go. So the x is going to go in front of the log, and this is our power rule. So we get x log 2 is equal to log of 11. And simply, what is our last step? Think of it as a regular algebra equation where you're just solving for x. So you're going to divide both sides by log 2. So we get x is equal to log 11 over log 2. This is your exact answer, but because we want it in decimals, can somebody tell me what log 11 divided by log 2 gives us to 3 decimal places? X is equal to approximately 3.459. Thank you, Matthew. I have a feeling you guys are going to find this one a lot more easier because you can just automatically put a log in front of everything and then call it a day. So the next one we have is 5 times 4 to the 2x is equal to 25. So the first thing we need to do is divide both sides by 5. So you get 4 to the 2x is equal to 5. And what do we do next? You're going to put a log in front of both. So you have log of 4 to the 2x is equal to log of 5. And then the 2x comes in front, so we get 2x times log 4 is equal to log 5. And then all we have to do is divide both sides by log of 4. So we get 2x is equal to log 5 over log 4. And then because we have the 2 in front of the x, we just divide both sides by 2 again. So we get x is equal to log 5 over 2 log 4. And who can tell me what that gives us to 3 decimal places? 0.580. So does the first one seem easier or does this one seem easier? Both are basically the same idea, except one you have to put with the same base, and the other one you can just attach a log in front of both numbers. So the next one we have is 6 to the power of 2x plus 3 is equal to 29. So the first step, as usual, is to put a log in front of the terms. So you get log of 6 to the power of 2x plus 3 is equal to log 29. And then we bring the exponent to the front with our power rule. So you get 2x plus 3 times log 6 is equal to log 29. So what are we going to do with 2x plus 3 times log 6? Nope, we're not going to divide by log 6. I mean, you can divide by log 6 if you wanted to, but for the sake of using the rules of log, we are going to distribute the 2x plus 3 into log 6. Then I'll show you the easy way after. So you have 2x times log 6 plus 3 log 6 is equal to log 29. Okay? So what we're going to do next is we're going to move the 3 log 6 over. So you get 2x times log of 6 is equal to log 29 minus 3 log 6. And based off our power rule, 3 log 6 is just simply log 6 to the 3, which is equal to log of 216. And when we're subtracting logs together, what type of rule are we using? Product rule, quotient rule, or power rule? So we're going to be using quotient. So we're going to divide both sides by 2 log 6. So we're left with x is equal to log of 29 over 216 divided by 2 log 6, which is just log of 36. And what is our solution to this question now? Can someone tell me what log of 29 over 216 divided by log of 36 is? Negative 0.560. Now I'll show you the other way that doesn't involve any log rules, but because I want you guys to use the rules of the log, this is why I did it this way. Or so you would just evaluate log 29 divided by log 6. So you get 2x plus 3 is equal to 1.879. Okay, you move everything over. You get 2x is equal to 1.879 minus 3, which gives us negative 1.120. Divide both sides by 2, and we get x is equal to negative 0.560. So as you can see, the way we did it, I wanted you guys to use the rules of logs. But the other way is just basically dividing the logs together and then just having a decimal and then just isolating for x. So it's basically the same idea, except you're not using any log rules at all. So our next example, example D, we have is 5 to the x minus 1 is equal to 3 to the power of negative x. So all we're going to do first is put a log in front. So what happens to both of the exponents? Where do they end up going to? They go to the front. So we get x minus 1 log 5 is equal to negative x log 3. So now we're going to distribute the x minus 1. So you get x log 5 minus log 5 is equal to negative x log 3. So we're going to move all the like terms to one side. So we're going to move the negative x log 3 to the left. So we get x log 5 plus x log 3 is equal to log of 5. Is there anything that we can factor out from the left side? So we're going to factor out our x. So you get x times log of 5 plus log 3 is equal to log 5. And when we're adding logs together, what type of rule do we have? So we have our product rule, which means we're going to multiply 5 and 3 together. So you get x times log 15 is equal to log 5. And what is our last step? We're going to divide both sides by log 15. So we get x is equal to log 5 divided by log 15. And what is the approximate x value? $0.594. So is everyone fine with this method that we're doing right now? Oh, so from x log 5 minus log 5 is equal to negative x log 3. So what we did there is because negative log 5 doesn't have an x, it is not a like term on the left side. So we moved all the x's to the left side. So we brought negative x log 3 over, and we brought negative log 5 to the right side, which is why we got on the left side x log 5 plus x log 3, and on the right side we ended up getting just log 5. So it's basically like algebra, you're just moving everything with the variable over and all the coefficients over to another side. So we brought negative log 5 over to the right side, and we brought negative x log 3 to the left side. So now we're going to talk about exponential formulas and what they mean. So we have a half-life formula. So m of t represents the remaining mass after time. MO is the original mass. T represents the elapsed time. And H represents the half-life of the radioactive substance. So remember, T has to be in the same units as H. So if H is in minutes, T has to be in minutes. If H is in hours, then T has to be in hours. And then we have the double time formula, which is NT is equal to NO times 2 to the power of T over D. So NT represents the mass after time, NO is the original mass, T represents the elapsed time, and D represents the doubling period. So now we have compound interest, which is everyone's favorite formula because you see your money grow. So you have A is equal to P times 1 plus I to the power of N. A represents the amount accumulated over time. P is the principal amount of money invested. I represents the rate of interest per conversion period. And N represents the number of conversion periods. So if we have 12% per year, and we compound it, let's say semi-annually at, let's just say, 5 years. So when I say semi-annually, how many payments are you making each year? So when I say semi-annually, how many payments are you making a year? You're making 2. Okay, because semi-annually means once every 6 months, so you're making it twice a year. So when we see this, we have to divide our 12% by 2. So our interest would be 0.12 divided by 2, which gives us 0.06 every 6-month period. That's what the amount of interest we're gaining. And for our N, we are making a total of 5 years times 2 payments a year, which is 10. So in 5 years, we are making a total of 10 payments if we are investing every half year. So for example, this is what I'm doing. If I'm investing bi-weekly, how many payments am I making per year? $104 payments a year, okay? That's what it would be if you were doing it bi-weekly. So we're gonna get into the first example. So we have strontium 90. So I think this is chemistry. Chem people, have you guys heard of strontium 90? Or have you had a question like this in chemistry yet? Oh, that's physics? Okay, never mind. If it's physics, it's physics. I thought it was something for chemistry. So strontium 90 has a half-life of 25 years. How many years does it take for a 20 milligram sample to decay to a mass of 2 milligrams? So right off the bat, we're using our half-life formula. So we have MT is equal to MO times 1 over 2 T over H. So what is our MT value? What is the final value or mass that we have? 2. So MT is 2. What is our starting sample? Our starting sample is 20. What is our H? What is our half-life? 25 years. Okay, remember years is important, which means we need to figure out what T is, and T has to be in years as well. So now we're just going to plug it into the formula. So we get 2 is equal to 20 times 1 over 2 T over 25. So what is our first step? What can we do to both sides? So we're going to divide both sides by 20. Here is where I don't get mad if you use decimals. So use decimals. So you get 0.1 is equal to 0.5 T over 25. So based off what we did this lesson, what would our next step be? Not get the same base, but put a log in front of both of them. So you have log of 0.1 is equal to log of 0.5 to the power of t over 25. Then we bring the t over 25 to the front. But if someone does log 0.1 on their calculator, what does it give us? -1. So we get -1 is equal to t over 25 times log of 0.5. Now we just isolate for t. So we can bring the 25 over by multiplying, so we get -1 times 25 is equal to t log 0.5. And then what's left to do is divide both sides by log 0.5. So when we do -1 times 25 divided by log 25, log 0.5, what does that give us? So therefore, it would take about 83 years for the sample to be 2 milligrams. So is everybody good with that example? Okay, perfect. We have 2 more questions, and then you guys are free to go. So the next one we have is a bacteria culture starts with 10,000 bacteria, and after 40 minutes, the count is 30,000. What is the doubling period? So we have to use our doubling period formula. So we get NT is equal to NO times 2 to the power of T over D. So what is our final amount? What is our NT? NT is 30,000. Our NO is 10,000. Our T is 40 minutes. And our D is unknown. So we're just going to plug it into the formula. So we get 30,000 is equal to 10,000 times 2 to the power of 40 over D. What are we going to do first? We're going to divide both sides by 10,000. So we're left with 3 is equal to 2 to the power of 40 over D. Now we're going to add logs to both sides. So you get log 3 is equal to log 2 of 40 over D. And for this one, we're going to use our power rule. So we're going to bring the exponents over to the front. So we get log 3 is equal to 40 over D log 2. And then all we have to do is isolate for D. So we're going to bring the D over by cross multiplying. So we get D log 3 is equal to 40 log 2. And what is our last step for this question? We're going to divide both sides by log 3. And what is our approximate value? It's going to be about 25, and because T is in minutes, that means D is also in minutes. So therefore, the doubling period is 25 minutes. And then our last question is Avery invests 2,500 in saving certificates at an interest rate of 0.8 cent, 0.5% per year, compounded semi-annually. How long will this take for the sum to increase to 3,500? So we have our formula. A is equal to P of 1 plus I to the power of N. So what is our A? What would our final amounts be in this question? $3,500. Our P is 2,500, and our interest is 0.085. And because it's compounded semi-annually, what do we have to divide by? 2. Which means our interest rate is 0.0425. And now all we're going to do is use our equation. So we have 3,500 is equal to 2,500 times 1.0425 to the power of n. We're going to divide both sides by 2,500. Again, feel free to use decimals here. So we got 1.4 is equal to 1.0425 to the power of n. And like we learned today, we're just going to put log in front of both numbers. So we got log of 1.4 is equal to log of 1.0425 to the power of n. And what happens to that n value? Where does it end up going? To the front. So we get log of 1.4 is equal to n times log of 1.0425. And what is our last step? So isolate for n. So n is equal to log of 1.4 divided by log of 1.0425. And what does that give us approximately? So n gives us approximately 8. So now we have to ask ourselves, if n is 8, that means we're paying 8 times within this period, and we need to take into account the semi-annual parts, okay? So if this is 8 conversion periods, realistically, how many years is that? So what would we have to do with the 8? So remember 8, so remember semi-annually is you're multiplying the n value by 2, and then we have 8 conversion periods. So we would divide by 2 to get our n, which means n is equal to 4 years. And that's a pretty crappy return for 4 years. Okay, so that's pretty much it for this lesson. As you can see, that was a pretty long one. It took me about an hour